Ambatovy is one of Africa's biggest industrial projects and the largest single investment in the history of Madagascar. Once fully operational, Ambatovy will supply approximately 10% of the world's cobalt and 4% of the global demand for nickel, which will in turn find their way into hundreds of products, from cell phones and utensils to high-tech turbines and specialized industrial alloys. The process of transforming raw ore to fully refined metals begins at the mine site, located outside the city of Moramanga, in the highlands of eastern Madagascar. Here, millennia of heavy, tropical rains have leached away much of the original matter, leaving behind a type of soil commonly known as laterite. Widely found in the tropics, laterite's characteristic rust color is due to the presence of high levels of oxidized iron. The soil at the mine consists of 3 distinct layers, or strata. The surface layer, found just below the topsoil, is known as ferrocrete. As its name implies, it's an extremely hard crust, up to 3 meters thick, with a high level of iron oxides. Sitting farther below, just above the bedrock, is saprolite, another form of heavily weathered soil. In between the ferrocrete and the saprolite is limonite, an easily crumbled soil of predominantly fine particles. It's in the limonite that nearly all of Ambatovy's economically viable nickel is found. Consisting of 1% nickel and 0.1% cobalt, the reserves at the mine site are sufficient to supply Ambatovy for at least 27 years. Despite the presence of many minerals other than nickel and cobalt, ore mined by Ambatovy contains no precious metals, such as gold, platinum, or silver. Nor does it contain precious stones, such as sapphires, for which Madagascar is well known. All ore at Ambatovy will be extracted by surface mining. Before a location is mined, Ambatovy's environmental team inventories it thoroughly. Clearing is done slowly and in one general direction. This enables animals, including more than a dozen species of lemurs, to migrate to safe havens in adjacent conservation forests. Plant species of special concern, including unusual and rare orchids, are transplanted for preservation and propagation. To date, more than 100,000 specimens have been relocated. These species will be used during future reclamation and revegetation of the mine. After clearing, felled timber is directed to local communities for their use. Topsoil and plant debris are saved for reclamation purposes. Timber that cannot be used by local communities is chipped into mulch. Ambatovy's nurseries provide a stock for reforestation activities. An industrial-sized nursery is being developed, along with community nurseries. Compared to the amount of forest lost every year in eastern Madagascar to agriculture, traditional uses, and logging, the amount of forest converted by Ambatovy is very small. In fact, every year the amount of forest lost to human activity in this part of Madagascar is calculated to be more than 100 times greater than the amount of forest Ambatovy will use over the next 30 years. Additionally, through the Business and Biodiversity Offsets Program, Ambatovy is committed to the conservation of 9 hectares of forest for every hectare of forest converted during mining and operations. Once extracted, the ore is sent by truck to the Ore Preparation Plant, or OPP, located on the mine site. At the OPP, rocks and sand are separated from the laterite, which is then screened so that only particles 3/4 of a millimeter in size or less are let through. Water from the Manguru River is transported through a 30-kilometer pipeline and added to the laterite, creating a slurry that is approximately 35% solids and 65% water. The amount of Manguru River water used by Ambatovy will on average be less than 1% of the annual flow, possibly reaching up to 5% in the dry season. Ambatovy is taking steps to make sure that this does not impact traditional use of the river in any way. From the OPP, the slurry is pumped into a pipeline, where it begins a 220-kilometer, 30-hour downhill journey to the plant site, which is located outside the Indian Ocean coastal city of Tuamasina. For nearly all of its length, the pipeline was buried using standard cut-and-cover construction to an average depth of 1.5 meters. Extensive rehabilitation over the course of the pipeline is already returning the landscape to its natural state, minimizing the potential for erosion. The plant site is a vast industrial complex covering more than 320 hectares, or about the size of 250 football fields. At the plant site, the ore undergoes numerous steps, collectively known as the hydrometallurgical process, which ultimately yields refined nickel and cobalt. As indicated by its name, the hydrometallurgical process makes use of water and other chemical compounds to progressively separate nickel and cobalt from the other materials present in the ore. Upon arrival at the plant site, the slurry enters a thickener, essentially a very large tank where solids are allowed time to settle out. The thickened slurry next moves into a battery of 5 extremely large vessels known as autoclaves, which are effectively enormous industrial-scale pressure cookers. It's in the autoclaves that the hydrometallurgical recovery process, a time-tested technology developed and perfected over the last 50 years, truly begins. Inside the autoclaves, the slurry is heated and pressurized, and then mixed with sulfuric acid as part of a process known as pressure acid leaching, or PAL. In the autoclaves, the temperature of the mixture is raised to 250 degrees Celsius and subjected to 5,000 kilopascals, or 50 times normal atmospheric pressure at sea level. The combination of sulfuric acid and high temperature dissolves the nickel and cobalt into a liquid solution. Undissolved solids, mainly iron oxide, remain in the slurry. To prepare the slurry for further processing, it must now be neutralized. This is done by the addition of limestone, making gypsum precipitate. The neutralized mix is then decanted progressively in a series of large tanks. In these tanks, the solution containing nickel, cobalt, and other minerals is separated, and unwanted solids settle to the bottom. Materials with no economic value are treated and pumped via a 15-kilometer pipeline to a 750-hectare tailings facility, a secure, stabilized area where neutralized waste products from the plant site are placed for permanent safekeeping. The tailings facility has been built to specifications consistent with the requirements of the International Finance Corporation. Over the 30-year life of the project, the tailings facility will be progressively filled with inert waste materials and covered by shallow lakes, the surface of which will gradually rise as the tailings continues to be filled. Eventually, these shallow lakes will disappear and the area will be reclaimed to resemble the surrounding terrain. At the plant site, decanting and neutralization continue by the addition of limestone. Gypsum precipitates, as well as impurities such as iron, aluminum, and chromium. Nickel and cobalt remain in solution with other dissolved impurities, such as calcium magnesium, sodium, and manganese. To separate still other minerals, the solution is heated and mixed with hydrogen sulfide. This causes the metals to solidify as metal sulfides. These metal sulfides now move on to the adjacent refinery for additional processing. The purpose of the refinery is to separate the nickel from the cobalt and to bring both to industrial levels of near complete purity. Many extractive industries in sub-Saharan Africa have chosen to refine their minerals in Asia, Europe, or North America. Ambatovy's decision to fully refine its nickel and cobalt in Madagascar entailed an additional investment of $800 million and guarantees more than 1,000 jobs for Malagasi's for at least the next 3 decades. The first step of the refining process is to return the now solid materials back into a liquid state. Residual iron, aluminum, copper, and silica are then removed through a variety of processes, including precipitation, sedimentation, and filtration. Residual zinc is removed by the addition of ammonia, and nickel and cobalt are separated by solvent extraction using organic solvents, creating 2 purified solutions, one containing nickel and the other containing cobalt. Hydrogen gas is added under high pressure to these solutions, which causes the nickel and cobalt to precipitate into a solid form. Following cleaning and drying, the fully refined nickel and cobalt are heated and compacted into small briquettes for shipment. Through evaporation, the residual solution from the refining process is crystallized into ammonium sulfate, an agricultural fertilizer in wide use around the world. Once at full production, Ambatovy will produce 60,000 tons of refined nickel, 5,600 tons of refined cobalt, and up to 210,000 tons of ammonium sulfate fertilizer every year, making Ambatovy one of Madagascar's largest and most important exporters. Prior to Ambatovy's construction, Madagascar had little of the infrastructure or industrial capacity required by a project of such scale. In fact, construction activities at Ambatovy began with virtually no supporting roads or utilities, making Ambatovy one of the largest greenfield mining projects currently underway anywhere in the world. This meant that in addition to developing the mine site, pipeline, and plant site, Ambatovy had to build extensive infrastructure as well as facilities to produce many of the inputs required by the project. Major industrial facilities constructed by Ambatovy include a coal-fired steam and electricity generating station, which includes 3 units rated at 45 megawatts each, plants to produce oxygen, hydrogen, sulfuric acid, and hydrogen sulfide, a water treatment plant. All of these have been constructed to international standards, maximizing worker safety while minimizing potential environmental risk. Major inputs that are not currently commercially available in Madagascar and must be imported include coal for steam and electricity generation, limestone for neutralization of acidic mixtures, sulfur for the production of hydrogen sulfide, ammonia for use in the refinery, and sulfuric acid for use in pressure acid leaching. While coal and sulfur are expected to be imported throughout the life of the project, Ambatovy is currently exploring a source for limestone on the western coast of Madagascar. When fully operational, Ambatovy expects to export approximately 275,000 tons of finished materials every year. Imported commodities required for this production will total approximately 3.4 million tons, or nearly 13 times greater than the amount of finished goods to be exported. This huge volume required a substantial expansion of the transportation infrastructure in Tuamasina. One of the piers at the port of Tuamasina, Mole B, was extended by more than 200 meters, and extensive materials handling equipment was installed. The 11-kilometer railroad line between the port and plant was rehabilitated, and an entirely new second track was added. Similarly, the road between Tuamasina and the plant was upgraded with pedestrian overpasses and fences installed to ensure safety for community members. An ammonia storage facility has been constructed, approximately midway between the port and the plant site. A 13-kilometer pipeline transports the ammonia between the two locations. Like all Ambatovy's pipelines, this one has been buried to avoid tampering and to ensure safety and reliability. Special public information sessions are held with local community members regarding the ammonia facilities to underscore the importance of everyone's responsibility for ensuring the highest level of safety at and around Ambatovy operations. Ambatovy is a mining and industrial enterprise of unprecedented scale in Madagascar. Yet environmental protection and employee health and safety are just as important to Ambatovy as financial results or the production of finished products. Ambatovy's pioneering environmental management and social development plan concerns every aspect of the project and frequently goes beyond what is mandated by national regulations and international conventions. Erosion control measures have been put in place wherever necessary. Plant and animal species of concern are relocated for preservation. To protect streams and rivers, large barrages have been constructed. These installations maintain water quality for local wildlife and neighboring communities. In fact, almost all of the water used by Ambatovy, whether for transporting the ore from the mine to the plant site or for use during processing and refining, eventually reaches the tailings facility. There, the neutralized solids settle out of the slurried tailings, becoming a solid base upon which vegetation will eventually be grown. Over time, water that reaches the tailings becomes clear of solids. This clear water is then sent down a pipeline and diffused harmlessly into the ocean, 1.5 kilometers offshore. Once diffused into the ocean, the mineral content of the tailings water, which is already quite similar to that of seawater, is rapidly absorbed by the tremendous volume of the ocean itself. This method of discharging water into the ocean has been repeatedly tested, conforms to international standards, and is environmentally benign. Emissions released into the atmosphere by Ambatovy are within standards set by regulators and international bodies such as the World Health Organization. They represent no threat to the environment or neighboring populations. Most are dissipated rapidly by prevailing coastal winds. As with all Ambatovy operations, these emissions are continuously checked by the latest generation of environmental monitoring equipment. Despite these precautions, Ambatovy is an industrial enterprise that requires the use of powerful equipment and potentially hazardous materials. In such circumstances, minimizing the possibility of an accident, whether caused by human error or mechanical failure, is of paramount importance. Ambatovy's safety management system is a comprehensive system that strives to minimize these risks while maximizing readiness in the unlikely case of an accident. Continuous training, constant maintenance, daily inspections, comprehensive response protocols, mechanical and electronic redundancies, and emergency preparedness are all part of Ambatovy's safety management plan. Rigorous internal standard operating procedures are backed by recurring verification, undertaken by independent experts and regulatory authorities. Ambatovy's ultimate success as a business enterprise will be measured not just by the financial bottom line, but also by its success as a responsible steward of Madagascar's natural endowment and by its record as an employer that puts employee and community safety first. From groundbreaking in 2007 to production in less than 5 years, Ambatovy's nickel and cobalt mining and processing operations represent a true transformation of Madagascar's industrial capacity, turning Madagascar's rust-red soil into one of the country's most important exports. Ambatovy, Madagascar's premier industrial partner.